Look at that. Beautiful, isn't it? But Jupiter acting all weird right now. The giant planet swirling clouds are changing color. The great spot is shrinking and turning orange.
What? And just over a little while ago, maybe a week ago or so, something smashed into it.
We learned about that, yeah.
What's going on? We're going to turn to York University's Professor of Astronomy, Professor Paul Delaney, on the line. Good morning, sir.
He knows all about Jupiter.
Good morning, good morning.
Okay, what's going on with Jupiter? It's a hot mess. What's happening?
Well, Jupiter is a big planet, and its gravitational field tends to do weird and wonderful things. Acts a little bit like a vacuum cleaner, so it sucks objects into the atmosphere at tens of kilometers a second, and it spins on its axis once every 10 hours. So that generates a lot of energy in the upper atmosphere. So changes in the cloud patterns, changes in the red spot, believe it or not, are pretty normal. But we're watching it now with ever-increasing detail. So every time it sort of blinks or hiccups, we actually see it, and that gives us greater insight into the way the planet is actually operating beneath the cloud tops.
So these are essentially things that have probably been going on for a long time, but we now have the technology to see it. How does it benefit us to learn about Jupiter and the changes going on there?
Well, it's a very different planet to our own Earth. It's what we call a gas giant for very obvious reasons. But to be able to understand how all planetary activity occurs, if you will, what its genesis is, even on Earth, you need to have more objects to observe. So that's one of the reasons we go to Mars, why we go to Jupiter, to be able to analyze what's actually happening and to be able to model it. Because those models, if they improve, let's face it, the weather system on Earth is a bit chaotic, the weather system on Jupiter is a bit chaotic. There's a lot more in common than you think. So to be able to have another data point, another object to test out your models actually improves the weather predicting capability here on Earth.
What are the other strange behaviors that are happening, and what does it signal to you as you're studying?
Job security, because things are always changing, so that's great. But I mean, yeah, when all is said and done, Jupiter is the object to observe because it is so very large. Every aspect of Jupiter is a little bit mind-blowing, a little bit mind-boggling. I mean, all of the satellite systems, the satellites that are orbiting and the possibilities of life. When we look at the cloud tops and the way they are interacting, the gravitational field, the magnetic field, all of it tells us that we've still got lots to learn about planetary formation. And when we're talking about billions of planets, hundreds of billions of planets probably in the Milky Way galaxy, of which many are likely Earth-like, the more we can find out about these planets right here at home, the better off we're going to be when we're looking at those exoplanets.
And let's talk a little bit, the collision. I'm trying to remember how big the object was. I think it was the size of Earth, was it, that collided with Jupiter?
No, it wouldn't have been that big. You're referring to the one that the amateur astronomer found about 10 days ago, or saw on a video capture, right?
Yeah.
Yep, just making sure we're on the same wavelength here. No, it was probably several hundred meters, perhaps a kilometer or two in diameter. We actually don't know because we only sort of caught it for like literally 1 second. All of our follow-up observations are suggesting to us that it was likely several hundred meters in diameter, so nothing like the size of the Earth, which is fine because, I mean, if it was something that big flying around our solar system, I'd like to ask my colleagues why we hadn't seen it before. But, you know, a few hundred meters in diameter, that size material from the asteroid belt, very, very common. And as I said earlier, Jupiter is such a large gravitational field, it really does act a little bit like a vacuum cleaner, and it pulls those things in often, but you've got to be in the right place at the right time to actually see it and capture it on video.
I was going to say, does the energy at all affect the way we function here on Earth? Because I just spilled coffee on my white shirt, Professor. Is it messing us up?
Is Jupiter to blame?
Is it the energy?
Really. The energy of these sorts of impacts is phenomenal. When it happened in 1994, there was like 25 impacts in a row that were all about 1 kilometer in diameter, screaming into the Jovian atmosphere. That was the impact of comet Schumacher-Levy 9. The welts on Jupiter were visible from Earth literally for weeks after. So these events do release a phenomenal amount of energy. Be thankful it's happening on Jupiter and not here. Yeah. Because, you know, if that sort of stuff happened here, we're talking about dinosaur extinction stuff. So no, out on Jupiter, it's fine. It's a big enough planet to absorb these types of impacts and carry on.
All right, what do you like about Jupiter?
Well, the fact that, it can be seen through the light pollution of Toronto, the fact that it's got swirling bands of cloud that are always changing, the Great Red Spot. Jupiter is always different when you look at it. There is always something new to observe. And then the Galilean satellites moving backwards and forwards. I mean, they're visible in the same field of view. Every aspect of Jovian observations, to me, is really quite thrilling. And for an amateur astronomer who's just getting into it, for example, it's one of the best objects that they could possibly imagine. They can see the disk, they can see all of this action, and they can see it in a bright city environment. So Jupiter is, in my opinion, the go-to object to look out for both amateurs and professionals.
Speaking of go-to, we can't get there yet, but there is Jupiter, Florida. Beautiful place, great restos.
Lot closer, that's true.
Closer.
And unusual people there at times, too, in Jupiter. It's actually baseball down there, too. It's great to be down there. One last quick question before we go. The new telescope you have behind you. Can people come check it out?
Absolutely. The first Wednesday in October, the beast behind me will go live with the public. So every Wednesday night here, we have public viewing. The telescope behind me, after we've finished its shakedown cruise over the next 3 to 4 weeks, that will be available for everybody to come and have a look through, as I said, the first Wednesday in October. So come along, set your diaries accordingly. It's a magnificent telescope, and it really shows wonderful objects in the night sky.
It's so funny. That's what I call Raj, the beast behind me. So many similarities, Professor Paul.
Wrap it up.
What can I say?
Thank you. Thank you very much, Professor. Thanks for joining us.